Hello again and welcome to what's left of my YouTube channel. Today I've got something which I hope and feel quite sure you're going to like watching and even building. Today's subject is a very good and low-cost preamp. The purchase of this product offers quite a wide range, so it will suit virtually everybody. I'm going to show you some details and show you the figures, and I would be amazed if you're not blown away and don't get onto AliExpress straight away and buy one of the options. I should, as usual, point out that I'm not on commission for this. I receive nothing from the makers of these kits. So my advice and comments, I don't care whether you buy one or not. It makes no difference to me. I have to mention that because so many people these days are sponsored by and they get the things free or something like that. I've paid for this out of my own money. And at this stage I'd like to thank Ron, who's done some testing for me. He's also bought this product, and he's stationed in America and I'm in New Zealand, so we communicate by Skype and compare notes. So these are the options of this kit. Now the kit is actually based on an Accuphase product. Now how close it follows the actual product, I have no idea, because I've never seen the Accuphase made preamp, other than to say the finished product costs a considerable amount of money. This is based on the Accuphase C-3850 preamp. It's available in 3 forms. You can actually buy the PCB for a couple of dollars. So if you want to do that and source all the components yourself, then that's an option open to you. The version that I have purchased is the complete kit and all the parts. The only thing it doesn't include is the power transform. That comes to an astonishingly low price of $17.25. Now that's New Zealand dollars, so you'll have to work that out in your own currency, but it's not a lot of money. The other option is to buy it ready made and reputedly tested. This option I haven't tested or have any experience with, but that's about 29 New Zealand dollars. So if you are capable of building it yourself, then the kit is the best option, because you're paying roughly $10 to have them build it, which is quite a lot in comparison to what the differences normally are. Anyway, let's have a look at the bench. Let's go to the bench and have a look at the product itself. What's included in the kit is everything on this PCB. What you will have to provide is a power transformer, details of that in a minute, and a volume control pot, preferably an Alps 50K log. This is not an Alps pot, as it's just one I've put on here for testing. The input will go in here, so the input goes into here, whatever plug you care to use. That goes straight into the pot and it comes out, and this is the input. Ground, left and right, or vice versa. This is the output lead. I've actually soldered a lead under the board, but the actual PCB has terminals here. well, it doesn't have terminals, it has solder pads, but you can see this is quite a thick cable, and to have that going into the top of the board isn't ideal. And it's basically about 2 feet long and has phonos which will plug into my power amplifier. Providing power is very straightforward. There's 3 terminals here, and it's basically, I've used a 15 volt AC transformer, and the yellow wire in this case is the center tap which goes to here, and the 2 effectively live connections go here and here. There's nothing magical about this transformer at all, because the power consumption is around about the 30 to 50 milliamps. So virtually any transformer, you can see by the size of this transformer, it's really small. At close proximity, there is absolutely zero hum from this circuit. This is the circuit diagram, which has been reverse engineered especially for you, and to the best of our knowledge there is no mistakes on it, but please use this for reference only and don't take it as gospel. So here we go. Power comes in here, there is a bridge rectifier here, and there is 2 regulators, a plus and a minus, because it runs on a 15 volt plus and minus supply. So the smoothing is here and here, and the whole circuit, you may think there's a lot of transistors on there, which there are, but there's only actually 2 types of transistors, and one of them is the BC560C and the other is the BC550C. You'll also see a chip here which is the obligatory NE5532. All the components on here appear to be genuine, even the chip. Now this is a true DC amplifier, in other words DC in, DC out, and it has probably the flattest and widest frequency response I have ever seen. Before we start looking at any real figures, let me tell you that this preamp has actually got quite a lot of gain, possibly more than you might need. I'm going to show you here with the aid of, excuse me looking down because my memory, I have to keep looking at my notes so I know what I'm talking about. The basic gain of the amplifier is just under 15 decibels, which is quite a high gain. Some amplifiers may not need anywhere near that sort of gain. Now, it's always beneficial for 2 reasons why you don't want, well, there's 3 reasons actually, thinking about it, why you don't want more gain than you need. Now, the first one, which may be obvious, if the circuit is very sensitive, it means that your volume control would be quite loud at say 9 o'clock, whereas you really want the gain control to be about 12-ish o'clock for average listening, which means that you've got a lot more control to get it really loud, but enough that you're not just off the stop of the potentiometer and you're getting to that part of the pot where the mismatch is quite common, and so you don't really want to be operating so you just turn it and it's too loud. That's one of the, if you like, cosmetic reasons why you don't. And the other ones are possibly less important in many respects, because this preamp is silent. There's no audible hiss and certainly no hum. You've got to be doing something really bad to get hum on, i.e. not screened cables. I mean, that's a no-no, I'm sure you know that. And you obviously don't want the mains transformer 1/4 of an inch away from the circuit board. But you saw how I've got it here, and that transformer is that close because that's how long the leads were. And bearing in mind, this is not a complete installation, this is me testing it, and in the real world it's silent, so you don't have to worry too much about that. The less gain the amplifier has, inherently the lower the noise level will be. And I can hear you say, well, if you can't hear the noise anyway, making it lower is kind of academic, which is true. If you couple that with the first reason, you can reduce the gain, and you can take the gain, I've got some numbers here where the gain is only just over 3 dB, which is very low. And I put resistor values on here, and I'll show you how to do this later on. But as it comes out of the box, the gain is, to be precise, 14.89 dB, which is a voltage gain of just over 4. Now, the other reason to reduce the gain, if you don't need it, is it will also decrease distortion, but again microscopic, because I don't have any means of accurately measuring distortion with the equipment that I've got, because the distortion is so low that I just can't measure it, because my equipment isn't good enough. And if I was rich, I'd have 10,000–20,000 pounds worth of test gear, but as I'm only a poor pensioner, we have to put up with this and leave it to maybe somebody else to measure it. It's microscopically low, but that is an effect. If you reduce the gain, you effectively get more negative feedback, and that's how you more or less reduce the gain. So you never want to have more gain than you actually need. Let's have a look now on how you can reduce the gain. As you see from this photograph, there's just basically one resistor that needs to be changed. Obviously one for each channel, so 2 if you like. And by default, it's a 100 ohm resistor. And you can see by the chart, which I'll put up now, the various resistor values you need to put in to change the gain. But if you're building this from scratch, what I suggest you do, don't solder this resistor in, but if you do, don't shorten it, because they're I won't say they're hard to get out of the board. On the grounds that you might want to change it, I suggest you put in a couple of pins, or maybe just a little bit of ½ an inch of wire sticking out, so you can just tap on the resistors. The other small modification you can make, don't worry, there's not hundreds of modifications, but again, if you look at the printed circuit board here, you'll see a 100 picofarad capacitor. You will see that this is basically an input filter, and before I say anything further, if you happen to live a few hundred yards from a transmitter of any frequency, don't mess with this capacitor, because you could end up receiving radio stations which, well, it's not a radio tuner, it's a preamp. Chances are you won't have a problem. You'd have to, because we have a transmitter, I don't know why I was going to point to it, but it's about a mile across the road, relatively low power, so I never get any problems with radio stations coming through on my circuitry. If you can reduce that capacitor, or I should say you can reduce that capacitor, it will widen the high frequency bandwidth. Now again, you could say, why would I need to do that when it already extends, although you don't know it yet, way wide, not 20 kilohertz or something like that. I'm going to show you later on. You'll be blown away. Just a thought, by the way, I've shown you where I obtained my boards from, but Ron purchased from a different company, because the company I purchased mine from don't sell the PCB separately. I'm only telling you about the one I've purchased from simply because that's where I purchased it from. But if you look on AliExpress, you will find half a dozen different companies, and I'm not endorsing one or another. The one I purchased from at the moment is offering free postage, and I have to say it's ridiculously low cost preamp to build, or even if you buy it ready-made. But please don't think it's rubbish. We're going to look at some figures now, and I think you will be amazed. We're going to start now looking at some square waves. Invariably I get comments from people saying, but we don't listen to square waves. Well, of course you don't. And equally, you don't generally listen to sine waves. Let's forget about the sine waves for the moment, because all that will demonstrate is the frequency response, basically. And if I tell you theoretically it's DC, but in reality it's about 1 Hertz, because the crossover between DC and 1 Hertz is something that's quite hard to measure. This preamp is flat, and if I tell you it goes over 300 kilohertz, flat, not 1 dB down, not half a dB, but flat. There's no ripples on it. You could literally draw it with a ruler, and I'm going to prove it. The comment is, as I said earlier, people say you don't listen to square waves. Music, the difference between a preamp or an amplifier, because it's still basically the same thing, except we're dealing with the low level works in a preamp, and the amplifier delivers the power and adds current. A preamp on itself is largely a voltage amplifier, and it takes the very small volts needed to drive the power amplifier. But it generally doesn't have a lot of power. But saying that, one of the beauties of this particular preamp is that it has a very low impedance output, and you can use it as a headphone amplifier, driving even 15 ohm headphones, and it gets surprisingly loud, and of course it's crystal clean. But we're not talking about headphone amplifiers. It's capable of doing it. What this preamp offers in terms of matching, and it has a relatively high input impedance, not as high as some FET ones, which can be in the order of several megohms. It's about 300k input impedance, which is still quite high for a transistor piece of equipment. It's typically much lower than that, 2 or 3k. But you want a low impedance on the output to drive your amplifier. And this is in the order of 20-30 ohms, so pretty low. So many people will say no one listens to square waves, which of course they don't. What a square wave does do, if you look at the sides of the square wave, it should be, as the name suggests, square. It shouldn't lean, and it shouldn't have any overshoot on it, or even undershoot, as in some cases. The square waves I'm going to show you on here amazed me. I have to say, I'm not easily impressed. I've been in the business a long time, and when you look at some amplifiers' square waves, the Quad 405 is a good example. It's not even a square wave. It's got sloping corners on it, and it's got this and that. So the difference is you can hear it, because if the sides of the square wave are literally vertical and not leaning at all or curved, effectively it's what is known as the slew rate, and it means it's the speed at which the amplifier can respond to a pulse. Now, music is millions of pulses of all different frequencies. A good example is a drum. When you hit it, and you know when it's a drum in real life, don't you? If you happen to be standing next to a drum, it's got that real attack. And if the amplifier has a very fast slew rate, it gives you the detail that you want. But if the amplifier is slow, it's hard to describe what it means is, but it appears to lose detail. Well, mainly because it does. If you go, it's loud. Apologise if you're on headphones, by the way. But if it's sort of, it doesn't sound the same. And it's the nearest way I can describe the difference between an amplifier with a poor slew rate or a fast slew rate. So that's what's important about square waves. Now, there are many other things you can measure with $30,000, $40,000 worth of equipment. But as I haven't got that, don't write off square waves, because you really can hear the difference. If you measure this, as both Ron and myself have done, you know it's going to sound crisp, clean and detailed, because you can measure it, you can see it on the scope. So I'm going to show you these, and you could also argue, why would you want the frequency response to go above 20 kilohertz when only the dog next door or bats can hear it? In real life, you are surrounded by an infinitely wide frequency range. Anything that makes a sound has harmonics extending way above what you can hear, but it does have an impact on the harmonics mixing with the harmonics that you can hear. The first graph I'm going to show you is the easy one, and it shows you a 1 kilohertz square wave. The blue trace at the bottom is the signal from the generator itself. The yellow is the output of the preamp. Now, they're not to scale, and the markings shown on the scope are taken with a ×10 probe. So, but the relevance of the levels are largely superfluous from this. All you need to see in there is comparing the input with the output. There is virtually no difference, but that's an easy frequency. Most amplifiers produce a decent square wave at 1 kilohertz. This is a 20 kilohertz square wave, and as you can see, it's almost indistinguishable from the 1 kilohertz square wave. Now, if you look at this particular slide, it's beginning to look, there's a slight slope on it, but if I tell you that is 100 kilohertz, I've never seen anything like it. But if you think that's good, look at this one. As you can see, the sides are starting to slope slightly. That is 250 kilohertz. The quad can't do that at 10 kilohertz. This is the last slide on the square waves and high frequencies I'm going to show you. I'm just showing it to you because you won't believe it if I don't show it to you. This is 300 kilohertz square wave. If you can show me a better square wave than that at that frequency, I want to see it. We're looking at the other end of the scale now, and what frequency would you think that is? It's displayed on the scope there. That's 10 hertz. Okay, 10 hertz square wave. And again, it just shows you the low frequency response. Now this may not look quite as hot, but that's 3 hertz, 3 cycles in old money. Look at that, 3 hertz. And to be honest, most of that roll off is my generator. This is 1 kilohertz, and if you look at the meter here, we're on the dB scale and 0 dB. So I will wind up the frequency now. Well, we're down all the way by 1/4 of a dB at 300 kilohertz. We'll go a bit higher, take it down to 1 dB. Well, I've gone as far as I'm going to go. I'm bored now. That's 600 kilohertz, and we are 1 dB down. Well, as you can see, we're still on the 0 dB scale, and it's still flat. Now you can see the pointer is actually wobbling about, and that's because that is 3 hertz. Well, that largely sums up this little project. I'd be very interested in anybody that has built these or will build them, and as to whether it's the pre-made one or you bought the parts, whatever. Leave your comments on here, because I do read all your comments, and I always try to respond by replying to them. I'm not going to say subscribe and all that, because it just drives me nuts. If you want to subscribe, that's great. If you don't, I don't care. Makes no difference to me whatsoever. YouTube doesn't recommend my videos anyway, so why should I care? But thank you so much for watching. I hope this has been useful and you enjoy building, but most important, you enjoy listening to this preamp.